right, this is one of those algebraic representation problem as well. And if it takes h hours to paint a rectangular wall that is x feet wide and y feet long, how many minutes does it take to paint a 1 square foot of the bulletin board? You know, this problem is very simple. But for a person just casually reading the problem, would automatically assume it's very, very difficult. The reason being is just there's so many terms that can lead to distraction. Okay, but if you stay true to the problem and the concept, you're going to get through just fine. So the basic premise is area of a rectangle, okay, is length times width, right? The length is x times width is length is y and width is x. So that is the area, and the unit of the rectangle is square feet, right? So it takes h hours, okay, to paint a rectangular wall that is xy square feet. We don't know the unknown area of the rectangle. But what if it only takes, how long would it take to paint a wall that's only 1 square feet? That's all this problem is asking, but it also wants the final answer in minutes per square feet, not hours per square feet. So if you do this math here, you get h over hours over xy, right, in square feet. So how do we go from hours to minute? It's 1 hour is 60 minutes. So that would be 60 h over xy, right? So the correct answer is B. So what might be, as I said, what might be tricky for a lot of you might be, how do I meaningfully incorporate all of this information into the problem? And the only way you can be successful with this type of word problem is to take out all the distraction and approach the problem for its simplicity, which is take the area of a rectangle, apply the variables in it, get the answer in square feet. Now you know the area of rectangular wall that's xy square feet in terms of dimension. And if it takes h hours to paint that wall, what would it take to paint a wall that's only 1 square feet? And then get that expression in terms of hours versus square feet ratio, and then convert it to minutes using the hours to minutes conversion, and you have the correct answer. All right, moving on. If Carol earns X dollars a week for 3 weeks and Y dollars a week for 4 weeks, what's the average number of dollars per week that she earns? It's a simple average problem in terms of, not average as in, it's one of the average concept problems. So Carol makes X dollars per week, right? So how much would she make in 3 weeks? She would make 3x dollars, right? Similarly, she makes Y dollars in 1 week. How much would she make in 4 weeks? She would make 4Y dollars, right? Now, when you try to average, what you would likely do is 3x plus 4y by 2. And you notice this is not a choice similar to what you wrote. This is incorrect because average is not just about how many quantities you have. You have one 3x and one 4y, so I'm going to average it by 2. Average doesn't work that way. You have 3 x's, that means x, x, x. Similarly, you have 4 y's, y, 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 y. So that means you have a total of 7 items. So average of the 3x dollars and 4y dollar should be 3x plus 4y by 7, not 2. Even though they could have technically made the problem more difficult by actually giving 3x plus 4y by 2, but they did you a favor by not doing that, because most of you would be tempted to go for that as the correct answer. But in fact, that is not the right way to do averages. You have, 1 week, 2 week, 3 weeks in terms of X. You have 1, 2, 3, 4 weeks in terms of Y. So you have total of 7 weeks. So you have to average the amount that Carol made over 7 weeks, not divide by 2. She didn't work for just 2 weeks. So that's why we divide by 7 and not 2. And that is the correct answer. So that would be answer B. Moving on. Tim bought a skateboard and 2 helmets for a total of D dollars. If the skateboard cost S dollars and the cost of each helmet could be represented by each of the following expression. It's very simple. We know one skateboard costs S dollars, right? Let's for time being assume that one helmet costs Y dollars, okay? So S, which is you purchase one skateboard and 2 helmets, and these 2 together cost D dollars, right? Right? So we know the cost of the skateboard is S dollars, right? So what's the cost of the helmet would be 2Y equals D minus S, Y equals D minus S by 2. Put that in bracket, put a dollar sign, even though that's not necessary. That's how you complete it, and you look at it, and the answer is C. Now, the key aspect of a problem like this is you have to assign a variable to the unknown aspect. And also, just as you read the problem, maybe read it one more time and read it out loud within your own mind and try to figure out a way to transform all the words in the question into a mathematical expression. And that's precisely what I did. And once you start practicing along those lines, then you perfect that skill and you would eventually be able to do these type of problems in a jiffy. All right, moving on. All right, this is one of my favorite problems in the set of essential math concepts. Now you're given x is root 6, y squared is 12, and you're asked to determine the value of 4 over xy. Now I gave this problem to 2 of my friends and a coworker who are just as much of a math enthusiast as me, and they took the longest approach. Trust me, they got the right answer, but at what cost? Time. Time is not something that's insufficient when you take a test like this, where you have limited amount of time and X number of problems to solve. So how can we solve this problem in a more easier way? And here's what I did compared to my friends to get the answer in a more faster way. So instead of trying to, take the square root of the y and make the problem more complicated than it really is, what I did instead is I decided to go the other way around. I instead squared this term 4xy, which resulted in 16 over x squared times y squared. Okay, what this does is it removes the square root on x term and let me keep the y as it is without taking square root of it. It's just a win-win all the way. So x squared now is, x is root 6, so x squared would be 6, right? And y squared is already 12. So you do not have to make any changes and you solve the problem very, very simple, right? 4 times 4, 4 times 3, 2 times 2, 2 times 3, that'll be 2 over 9. Okay, what's the big deal? How do I still determine which is there's nothing that remotely looks like 2 over 9. Start squaring, because we squared the 4 over xy term, start squaring all of the choices. Whichever one that results in 2 over 9, that's the correct answer. Since I have done the problem, I already know if I take the square root of this term, it'll be 2 over 9. Bingo, that's the correct answer. If you don't agree with me, let's do the others. Say A. Okay, let's square this. What do I get? I get 9 over 4 times 2. So that would be 9 over 8. That's not what we want. Let's do B. So A is incorrect. 2 root 2 over 3. Well, that's quite the opposite of what we just did. doesn't matter, let's do it anyways. It's 8 over 9, that's not what we want either. Let's go to C, it's 3 over root 2. In fact, the opposite is what we want, so it's 9 over 2. That's not what we want either. We want 2 over 9, so C is incorrect, so D is D. Now, this is probably not taught in any textbook. This is just something you have to do if you ultimately can't figure out what to do. So when I read this problem, I have not done this problem before, and this is what occurred to me because I don't want to take the square root of the y. So what I spent more time disproving choices A, B, and C than I actually did the problem to get the right answer, D. You are welcome to take the square root of y, plug it in x and y, and go the long route. I'm not going to do it because it's just simply practically too long, and I don't have, the purpose of my video is to make life simpler, not more harder. So that's how you do this problem, and the correct answer is D. Now stay tuned for more problems in this Essential Math series.